Hello. This is the start of a new course that I will be teaching and understanding with you all. This is Prerequisites Mathematics for ML. This day ML is very hot topic for everyone. Everyone wants to bring ML AI into their own systems, but many of us don't understand what is the mathematics behind this. So I have started this course which will teach you basics of maths and its component, which will be helpful to you in your ML learning. So I hope this course at least benefits some of you. And yeah, so let's start. Mm, so first of all, what do you think about Spotify? Like, Spotify suggests you songs. It suggests you what would you like, why will you like. So how does it know what will you like? Is it have any data of you? Does it have some kind of algorithm behind it? So it kind of uses ML, but how does it represent your data? How does it know you like certain songs or you don't like certain songs or what to show you next? So all kind of language of computer, how does it understand and what is its language? So basically, it understands you in series of what you call as vector. So this is like a universal language of ML systems. It's like 0101 is the basic language of the computers or keyboards and all the computers we use, laptops. So they have zero and ones as a basic alphabet. For ML systems, this basic alphabet is vector. And due to these, why have the ML systems been scaled to such a degree? Because now we have the perfect tool to expedite, to like just improve the language comprehension and the all the operations you can perform on a machine using this language vectors. That is, you have a GPU. So that's why the ML and AI has grown many times fold. So yeah, and so this is what we say about vectors. So, but what are vectors? So according to logical term or any mathematical term you can see on book or something, we'll see that it's an object that encodes a length and a direction and an origin. So vector is just what it is. It has three things. It starts from something because you can't exist if you don't start from something. So it has an origin. It has a particular length. It is of 1 units, 2 units, 3 units, and it has a particular direction. So it knows from which direction it points to. So that is very important for vector. Now, a vector is, you can see a vector v1 comma 2 isn't just a list. So what do you mean? What do I mean by this? So in simple terms, you can just assume that a vector is just order list of numbers. So vector is nothing but 1 comma 2. So this is like a list only. But what is it? What's the basic idea behind it? So it is an informed numbers. So this numbers tells you something about this vector. So this isn't just a list, but it's an arrow on a graph with a specific length, and it has a specific direction. So this we are saying at least like geometrically multiple, like you can have multiple meanings of this. You can say it is you can represent it by row, by column, you can represent it by coordinates. So by representing it with the coordinate, you are saying showing it geometrically. So this is all the basic crux of vector. So vector is nothing but an math object which encodes the length and direction. So yeah, so now before we go into this rules, I'll just show something to you on the whiteboard. Yeah, so it might take some time. Yeah. So yeah, we have. So vector, you can represent it by just something of an v equals to some 1 comma 2. This can be your vector. And another thing is you can also represent it in a vector space. So what is vector space? Vector space is just a closed loop among all these vectors. So whatever vector, like this is v1, v2 is something 5 comma, let's say 1. So then these two vectors are a part of a vector space, and vector space has both, like these are the only vectors where you can perform an operation. So if you couldn't perform operation on v1 and v2, they would not be a part of this vector space. They would be at a different vector space. So that is what you can see by vector space. Vector space is just a set of all these vectors, and these vectors are just the elements inside it. And you can display it like not this is like just by a row, so you can also display it by something of a column. So I can say this is 1, this is 2. So this is shown by column, this is shown by row. Both are correct. Both are correct. You don't have to worry about this. And then you can also represent it on some coordinate basis. So what we have shown is we have shown this by number. This is very good for like the operations in computer, but you can also show it by another way. So it has, what I said, vector has an origin. This is its origin. Now let's say this is 1 and this is 2. So this is like pointing towards uh, so this is like a vector. So vector has this direction, vector has this unit. So how do you calculate its length, and how do you add, subtract it all, etc. You can will know in detail now. So yeah. So this is what the what you can see, it's vector. Now let's move ahead. There's a how are these vectors communicate with each other, or how do we say they are like how do we perform its operation? So you can perform the operation by numerous ways. You can add it, subtract it. You can find its whatever like dot product and all. But first we'll understand how do you add it. So let's say there is one v1 as 5 comma 5, and there is v2 as 2 comma 2. So what if you want to add it, you just add the subsequent place. So 5 plus 2, 5 plus 2. So it will be v dash of like addition of v1 plus v2 would be 7 comma 7. 5 plus 2, 5 plus 2. So yeah, this is the addition. Either way, if you want to subtract it, so let's say I want to subtract the values, then I'll say v1 minus v2 is 3 comma 3. So this is like very simple. You just subtract this position with this and this with this. So it's like it's very easy. And then you can also kind of get the length of the vector. So to get the length of the vector, what you have to do is you have to find out the square root. So whatever this vector is, so these elements are 1 and 2. These are two elements here. So to find the length of this vector, you can just took a square root of it. So 5 square plus 5 square. So whatever the answer is, you can just that is the length of this vector, and same according for this. So you don't have to worry about calculating them. This is very easy. So formula for this is usually given as under root xi uh, multiplied by xj. So whatever the terms are here, xi, xj, xk, ln, m also. And this is like the square root of this. So 5 square, 5 square. So this is how you calculate the length. Yeah. So after this, we can have this important concept here, which is like the dot product and all. So for this, we'll just go back to slide and we'll know what am I talking about, what is these dot product and all. So for that, let's just share back into let's just share back into presenting. Yes. So these rules of a language, vector math. So we said the vector is our language for ML systems. So what are the rules of this language? That are these basically operations. So first we have to understand vectors in Rn. So Rn is nothing like if a vector v equals to v1, v2, vn exists. So in an n dimensional place, you can draw one dimension, two dimension, three dimension. We can't draw fourth dimension. This is basically one, this is like two, this is you can draw it on the like three dimensions also, but you can't draw more than that. But there exist more dimensions than that. So if all the components of this vectors like v1 v2, let's say v1 has component as 1 comma 1. So after doing this operation on this, if these elements are like real number, then we are say that it's a real vector, and it's a real vector of n dimension. N dimension could be anything, one, two, three. This is like two dimension. So R2 is basically 1 comma 1. If I say it's R3, so then dimension is 3. That means it is 1, 1, minus 1, anything but with 3 dimension. So for example, n equals to 2, vectors v equals to 2 represents point 1 comma 2. First common component 1 is in x, 2 is in y direction. Length of its magnitude, you can, like I said, you can calculate by like 1 square plus 2 square. That is like whatever the result you get, that is like under root 5. So yeah, and the angle with x-axis indicates its direction. So what is its x? So 1 comma 2 is maybe this, so this is its angle theta. And then there's our operators on vectors, addition, subtraction, which I told, length and magnitude, which I also explained. Now dot product and angle between two vectors. So angle between two vectors is dot product, but there's some slight difference. So let's see what is this. So okay, sharing mathematics. Yeah. So yeah. So, but how do we compare the two vectors? So to compare the two vectors, we use this beautiful tool known as dot vector to find the relation between two vectors. What is it? It is nothing but the uh, v1 dot v2. It's the addition in this whole term. Like if let's say v1 is x1 and y1, and v2 is x x2 comma y2, then v1 dot v2 is basically x1 x2 multiplication plus y1 y2 multiplication. So this is like the addition, and this is like the addition, multiplication, and whole summation. So that is our dot product. So what does this dot product tells us? It gives us some scalar value, right? So let's see, if I have like this, let me erase it. Yeah. So if I have this, I get some value right from this. So the small angle, what if so we can also get one angle from the dot product, not necessarily dot product, but there's a theta formula also. So I'll show you theta equals to cosine inverse of first the vectors dot product, which we calculated right now, and then their magnitude. So this is their like magnitude. This gives us theta. So basically, what is the angle between those two vectors? So this is vector one, this is vector two. So what is the angle between them? Theta. So this we will get by this formula. So then, what does this theta say about that, and what does dot product dot vector say about that? So we have to look at it from another perspective. Let's say there are two music option. One is like music A. There is two second option music B. So how do you choose? So your ML algorithm sees on the past data and then it calculates the theta. If there is a small angle, then means that the similarity between listening to music A and music B is high. So that's why the vector points in a similar direction. And if the angle is very low, then the similarity is, if the angle is large, then the similarity is very low because vector points in different direction. So you can ask one thing, ki, what if the angles are exactly 90 degrees, then what do you do? So then there is another case which I'll discuss later also. But for now, yeah, this is the thing. And so you can, this is before we understand the 90-degree thing, there's this concept, linear combination of vectors. So it's very easy. It's like given a set of given a set of k vectors, let's say v1, v2, v3, vk. In a vectors case, a new vector is called the linear combination if there's a expression for it, which is alpha 1 v1, alpha 2 v2, alpha 3 v3, and up to alpha k vk. So alphas are all the scalars, that is real numbers. So example is this. So let's understand this. Like if I'm saying, let's say this is v1. Uh, yeah, yeah. So let's say this is where oh, I went to this, yeah. So let's say this is V1, this is V2, and this is V3. So let's say if we want to put this in this formula, then there is alpha 1, uh, 1, 2, minus 1. There is alpha 2, which is 1, 1, 0. And then there is alpha 3, which is 0, 1, minus 1. Okay, so if you do the calculations, then alpha 1 into 1, alpha 1, and then alpha. So you what do you do is, this is like the scalar multiplication. So you multiply this with all these terms, and then you only do the alpha, like position wise addition. So first position is 1 1 0, 2 1 1, minus 1 0, minus 1. So you do by this. So alpha 1 plus alpha 1 plus alpha 2 plus 0. So alpha 1 plus alpha 2. So this is like alpha 1 plus alpha 2. Then this is like alpha 1 plus alpha 2. And then, okay, so sorry, my mistake. It's not what it's how it's supposed to be. Basically, what you do is you multiply this all by alpha 1, this all by alpha 2, this all by alpha 3, and then you find this alpha 1 with this alpha 1 with like the same position you carry on. So in this you'll get the, so yeah, it's the same. What you do is, so it's uh, alpha 1 plus alpha 2, because alpha 3 is 0. Then another is 2 alpha 1 plus alpha 2, 2 alpha 1 plus alpha 2, and then plus alpha 3. This is the second, and third is alpha minus alpha 1, then 0 and minus alpha 3. So that is how this works. And these are the expressions. Then let's move ahead. So why am I saying this? So why am I telling you the linear combinations of vectors and all? Because it's an important concept for the next topic, which is linear independent and the linear dependent vectors. So what happens in ML is you got some data. That data is like can be of whatever format, but you have to first clean the data to make anything out of it. So there can be some features where the both are very redundant, like the same thing is happening in the data. So that is very redundant. We don't want that. If same information is getting all through all the features, then we don't need that feature. Like we can reduce it. So for that, we find the linear independence and linear dependence vectors, and then we find how do we find the linear independence and dependence by that by this linear combination of vectors. So we say let's say a set of n vectors v1 to vn is linearly independent if the equation, the alpha 1, this is the linear independent linear equation of vectors. So all of this equals to 0 vector. But for this, when all the scalars alpha 1 to alpha n are 0, that is, you cannot write any vector in the set as linear combination of each other. So like v1 is not of v2, or vn cannot be of v let's say 3. So they can any one of this can't be the linear combination of the another vector. That is the requirement for linear independence. And for linear dependence, you have to, if the vector equation of alpha on v1 is equals to 0 holds, the same equation equals to 0 vector, but some or all the scalars are non-zero. Like it can be like the sum alpha 1 can be 1, or this can be alpha minus 1. So if 1 minus 1 and etc. equals to 0, and all the result is coming out to be 0 vector, then it's linear dependence. Like they depend on each other. This we can't have. We want linear independence. So let's see. So linear independent Li and linear dependent vectors. So I told you the definition. So we can see it by this example also. So 1 0 1 and 1 1. So let's see if we can show this here only. So let's say this is V1, this is V2. So I'll say alpha 1 of 1 0 and plus alpha 2 of 1 comma 1. So how will this go? So we have two equations. One is alpha 1 plus alpha 2. Okay, sorry, I haven't put the equation. So this is the complete equation, equals to 0. And then this is the first alpha 1 plus alpha 2. And then second is this is 0, so alpha 1 gets 0, alpha 2. Now both of this should be 0. So if we get by this equation, alpha 2 should be 0. And if alpha 2 is 0, we put this here. So alpha 1 plus alpha 2 equals to 0. And we know alpha 2 is 0, so we cancel that. So alpha 1 is also 0. So since alpha 1 and alpha 2 are 0, then we have this example of the linear independent vectors 1 0 1 1. Then we can see linear dependent in 1 1 3 3 also. So if we do this by let's say alpha 1 is minus 3, alpha 2 is 1. So what the result we get? So minus 3 1 comma 1 plus 1 3 comma 3 equals to 0. So what is this? Minus 3 plus 3 is 0. Then what is this? Minus 3 plus 3. That is also 0. So we get 0. But the alphas are not 0. They are some values like minus 3 and 1. Then this is like the linear dependent. So similar thing we can do for like R3 space also. So I'll just remove this first. So we can do this for multiple spaces also. So this is like an important part of the machine learning algorithm, and we will be studying this in depth after some lectures also. This is just like the basics of it to make you guys understand what happening really. So if I say let's do this for R3. So for R3 is like these are the vectors in the subspace 3. So 3 dimension means there are 3 units, 1, minus 1, 0. So this is like 3 dimensions. So we have this alpha's values are given. Alpha 1 equals to 1, 2 equals to minus 1, alpha 3 equals to 1. We put this in the equation. Then we can see like 1 plus 1, 0. Then like this is alpha 2 is minus 1, so this is minus 1, so 1 minus 1 0 plus. Then for like the second one, like this is minus 1, so minus 1 is like minus 1 0, but this is plus 1, so that is also 0. And here this is 0, so 1 into 0 0. Then minus 1 into 1 minus 1, 1 into 1 1, that is also 0. So this is like given here only, that like alpha's value are given here, and then this is like whole 0. So this is like S space is the linear dependent of set of vectors. You can also see this by v2 equals to v1 equals to vt through, if you do the v1 plus v3, that is 1 plus 0 1 minus 1 plus 1 0 0 1 1, so that is you'd get v2. So we are saying that these two vectors are linearly dependent with respect to v2 vector. So that is like the relation. So what about this? We say if what if the angle is 90 degree? So as I said, if the angle is small, there is high similarity. If the angle is large, then there is a low similarity. But what if angle is 90 degree? Then they are exactly completely different of each other. So that is like they are completely unrelated to each other. If they are completely unrelated to each other, should they belong to the linear independent or dependent vectors? So yeah, answer is linear independent, because both of their dot product is 0, and they are completely unrelated to each other, so that is they are linearly independent. So this is one point, that every orthogonal vectors of pair are the linear independent uh, in nature. So orthogonal vectors are what? Two vectors are orthogonal if their dot product is 0. Geometrically, they are perpendicular, which I talked about in the previous slides. Then let's talk about feature vectors in machine learning. So what are feature vectors? So let's say you have a data of an employee. They have like height and weight as a feature. So these are like the feature by which you can recognize. So each row here is a feature vector. It's a numerical representation of one employee. So let's say you as a human have multiple feature vectors. You have some height, some weight, you have some skin color, you have some qualifications, you have different facial structure, and also that all accounts into feature. So this is like all feature. So it's a numerical sentence that describes employee to the machine. So machine doesn't say, oh, it's an employee, it has this height and it has this weight. It recognizes, oh, this is like this is my employee, this is my space, and this is these are its features, feature 1, feature 2. So this is like the feature vectors. It's very helpful to recognize like what exactly are we looking for in the data. So this is like feature vectors. So yeah, so this was the end of the first lecture. We move with the coding part now, so that I could show you how am I doing this, like how are the operations taking place. So for that I have this. So we'll move with coding, and after code, we will stop this lecture. It just met me. Okay. So we will use the Python for this. It's very easy. Then uh, we are importing NumPy. So NumPy is a library to perform all the linear algebra operations, and it does it very fast. So this is very good library to know, get to know of. Most of you must have already known about it. Let's see, there's a equals to mp dot array. So it's an one dimensional array. Let's say one, uh, 4 comma 5 comma 6. This is a. Then b b is, let's say, 1 comma 2 comma 3. Then you can print a plus b, which is its addition. So 4 plus 1 5, 5 plus 2 7, 6 plus 3 9. You can also print minus, which is 3 3 3, because 4 minus 1, 5 minus 2, 6 minus 2, all is 3. Then you can also print the scalar version of vector. So uh, let us multiply this by 2 cross, this is the multiply operator. So 8 10 12, yes, so 4 2s are 8, 5 2s are 10, 6 2s are 12. Then you can also calculate uh, its length. So length, let's say it's np dot, uh, so linalg is like linear algebra, that you can use this to calculate the, like, use libraries of linear algebra, and norm is basically the uh, height. So you norm is basically the length, and I want to print L. So L is basically the A, which is 4 5 6. So 4 under root 4 square under root 5 square under root 6 square, that will give you the this value 8.7. So this is like the length, and then we'll calculate the dot product. So to calculate dot product, you just have to use the np dot function. It's very easy. And then you do A comma B. Then you just print this value. Yeah, so that is 32. So 4 into 1 4, 5 into 2 10, 14, 6 3s are 18. So 18 plus 14 is like 32. So yeah, this is a dot product. So yeah, this is the end of our class. Uh, in next in next sorry in next of the part, we'll understand the basic metric multiplications and like basic operations. How do we perform that? It will be more mathematical and less coding. This is also not much of a coding, but yeah, so we'll see about that in the next part. Thank you, hope you learned something useful. Yes, thank you.